Okay, now we are going to learn about set language and notation. And this is the question from PPT, from PPT provided in week 5 check-in 3. Okay, so in the first questions here, it's given the set. Epsilon here is equal to x, where x is integer, between 0 and 15. So there is a between, in between 0 and 15, inclusive. So I want to explain again, maybe you forget the meaning of inclusive. So inclusive means that 0 and 15 also included. If there is no word inclusive, it means 0 and 15 are not included, so between, so in between, so because there is word inclusive, so 0 and 15 are included on the list. So we can now first list the epsilon. So epsilon is the universal set, so everything in the discussion, so every element that is discussed in these questions is in the universal set. So epsilon here is equal to integer between 0 and 15 inclusive. So 0 also included, so 0, 1, 2, 3, 4, 5, 6, and then until 15. Okay, don't want to make it longer, so just write like that. Okay, so this is the epsilon, so integer between 0 until 15 inclusive. So and then now the k here is a, where a is a prime number. So k is prime number, so k of course included inside the universal sets. So the k maximum must be until 15 only. So the k here we can write, so the k is prime number. The first prime number is 2. Okay, so we can write 2, and then 3, 5, 7, and then 11, and then 13. And then done. We don't write 17 because the maximum is until 15, because the k cannot exceed the universal set. Okay. Now L is B, where B is an odd number. Okay, odd number B, L, so L here is equal to odd number. So start from 1, and then 3, 5, 7, 9, and then 11, and then 13, and then 15. So this is the last odd number. We cannot exceed the universal set. So this is K and L we already got. Then let's go to the questions. So the first question here is K intersect L. So K intersect L. So intersect, one more I want to remind you, intersect means that the common element between K and L. So we have to find the common element between K and L. So we can look at here. So we know that there is 3 and 3. Okay, so that's common. So we can write here is 3, and then what's the common again? So we have 5 common, and then we also have 7, we have 11, and we have 13. So that is the common number, the common element between K and L. So we can just list down all the common numbers. So 5, 7, 11, and 13. So this is K intersect L. Okay, done, easy. And then now the second part. Here is the K union L. Union means union, K union L. So united. Okay, so you combine the element in K combined with the element in L. So if there is a double element, so you just write it once. For example, here in L we have 1, but K there is no 1, so just write 1 here. And then K2, so we write 2, and then we write 3. There is no 4 for both of them, so we skip 4. And then 5, 6 there is no, and then 7, After 7 we get 9, 11, okay, and then 13, and then 15. Yeah, done. So this is the union. And the third one here is about the K complement. So this complement, yeah, L complement. So once more, I want to remind you the meaning of complement. So complement here is something that is not, yeah, or the inverse. Okay, so K complement, it means that the elements inside the universe but not K. Yeah, so we know K here is 2, 3, 5, 7, 11, 13. So now K complement here is the elements that is not K. So we can write here 0 is not K, right? So 0, and then 1, 2, 3 already there, and then 4, 5, and then already there, and then 6, 7 already there, so we don't write it. 7, 8, and then 9, and then 10, 11 there, no, then 12, 14, and 15. Okay, so this is K complement, and then we write the L complement, yeah, L complement. So something that is not L, yeah, so we can write here 0, and then 2, 4, so the even one, yeah, 4, 6, 8, and then 10, 12, 14. Okay, so this is the K complement and L complement. So the question in the third one is K complement intersect with L complement. So K complement intersect with L complement. So we try to find the common element. Yeah, here we have 0, 4, and then 6, 8, and then we got 10, 12, and then 14. So we can write here 0, 4, 6, 8, 10, 12, and 14. Okay, so this is K complement intersect with L complement. And now the fourth questions here is K intersect with L complement. So K without complement, yeah, K intersect with L complement. So we have L complement, yeah. I want to use green to find the intersection, to find the common element between K and L complement. So K here, and then L complement is here. So we compare with two of them. So we have 2, yeah, 2, and the L complement also 2, 3, no, 4, no, 5, no, 7, no, 8, no, 11, 10, no, there is only 2, yeah. So we can write here the K intersect L complement. Here is only one number, which is 2. So done. That's it. Okay, now we are in the questions 2. Yeah, so in the question 2 here, given the set epsilon, or the universal set here is 1 until 15, natural number 1 until 15, and then M here is a natural number also, but from 1 until 8, and N here is number 3, 5, 7, 9, 11. Okay, so in the question A here, draw a label Venn diagram to illustrate the set. Okay, so we are going to draw a Venn diagram. So we can make the box first, yeah. Okay, so this one. Okay, so we can make it like this, and then the pen here, we can write the epsilon, okay, representing the universal set. This is the box representing the universal set. Okay, and then here I want to write all the elements, yeah, so that it will be clear. So the M is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is all. So we try to make this to circle, yeah. Okay, so here this is for M and this is for N. Okay, so first we try to find the common element between M and N. Okay, so let's try to find. Here we have 3, one of the common element, and then 5 here, yeah, and then 7. So 3, 5, 7 is the common element. So we can write the common element in the middle here, yeah, 3, 5, and 7. Okay, so and then we can list down the element of M, which is not the common element. So the remaining element of M. So this is 1, 2, 3 already there, and then 4. Okay, 5 already there, and then 6, 7 already there, and then 8. Yeah, that's the element of M. And now the element of N. So the element of N is only 9 and 11. Okay, yeah, so done. And then after that we try to list all the remaining elements which is part of the universal set but not inside the circle. So want to try 1, 2 already there, 3, 4, 5, 6, 7, 8, 9, and then 10. 10 is not here, yeah, so I just want to write 10, and then 11 already there, and then 12, of course, 10, 12, and then 13, 14, and 15. Yeah, because the universal set until 15. So done. So this is the what is that, Venn diagram. Okay, this is how you draw Venn diagram. Now the part B, list the element of each of the following. So M union N. So M union N here, you just need to combine all the element in M and N. Yeah, so just write 1 and then 2, because here, yeah, all the element in M, 3, 4, 5, 6, 7, 8, and then plus also the element in N. The N we have 9 and also 11. So done. This is M union N. Okay, so now M intersect with N, so we try to find the common element. So we already list down, yes, this is 3, 5, and 7, something in the middle between M and N. So we just need to write 3, 5, and 7. Okay, done. And then now M complement intersect N. So M complement, we have to know first what is M complement, yeah. So M complement, let's list down here. M complement, something that is not N. So element that is not M, yeah, sorry, M. So M here is from 1 until 8. So something that is not M but is included in the universal set, it means from 9 until 15. So we just write 9, 10, 11, 12, 13, 14, and 15. So this is M complement. Alright, so now we try to find intersection between M complement and N. Okay, so N here we have 3, 5, 7, 9, 11, and then we try to find the common element. So 9 here, yeah, this is the common element. 9 with 9. Sorry, I want to use green, I think it's better. Okay, use green color. So 9 with 9, okay, yeah, and then 11 with 11. Okay, so I think that's all. There are only 2 elements, so we can write here. So 9 and 11. Okay, done. This is the M complement intersect with N. So now the fourth question is M intersect with N complement. It means we have to know first what is M intersect with N. we already got here in the second part, yeah, and then complement. So something inside the universal set, but not this one, the second one, not 3, 5, 7. So we can list down all. So 1, of course, and then 2, not 3. So we skip it, and then 4, not 5, 6, and then we skip 7, and then 8, 9, 10, 11, 12, 13, 14, and 15. So this is the answer. Okay, so now here the last questions is M complement, okay, yeah, M complement, a union N complement. So we don't know we know the M complement here already, but we don't know the N complement. So we have to list down the N complement. Here, what is the N complement? So something that is not N, yeah, but is part of the universal set. So we are going to list down the N complement. Here, where is it? Okay, so we can list down the N complement. 1, 2, skip the 3, and then 4, 5, skip 6, yeah, and then 8, and then 10, and then 12, and then what is that, 13, 14, and then 15. So this is N complement. Now we try to combine M complement with N complement, yeah. So we write all the elements in M complement and also N complement. So here we write the answer. So first I'm going to write 1, 2, 4, 6, 8. 1, 2, 4, 6, 8, and then 9, right? And then 9. Okay, and then 10, and then what again? 11, 12, and then next 13, yeah. Oh, sorry, 13, and then 14, and then 15. Okay, so this is the answer for M complement, union, N complement. So I think that's all for the question number 2. Okay, now we are in the question number 3. Okay, this is the questions. Of the 50 people, okay, so this is the total number of people, yeah. 50 people in a group, 6x minus 3 people own a car. So this is car, yeah. And then 4x plus 1 on a bicycle. So this is bicycle, okay. And then 2x plus 3 own boat. Okay, this is boat, yeah. Both car and bicycle. So 3x people do not own either car nor bicycle. So this is nor, yeah. Okay, so how many people in this group own a car but not a bicycle? So to solve this problem, we need to draw a Venn diagram. Okay, so we can make the square first. Okay, here make the rectangle, not square, get bigger. Okay, and then we make 2 circle intersect each other. Okay, so this one, why black? Yeah, okay, no problem. Okay, so I have 2 circle, and then this circle, the first circle is representing the car, and then this is for bicycle. Okay, sorry. Oh yeah, sorry. Okay, so bicycle. Okay, so now we are going to put the variable here, because in the questions we know 6x minus 3 on the car. So this is 6x minus 3 car, yeah. And then 4x plus 1 bicycle. So this is 4x plus 1. Okay, and then 2x plus 3 boat. Okay, this is 2x plus 3. Okay, so 3x is nor. So this is 3x outside the circle, yeah? Okay, so when we can see here, the middle part has 2x plus 3. So on the side here, on the car, on the bicycle, we need to minus with 2x plus 3. This one on the car part, we minus it with 2x plus 3. Okay, don't forget the bracket, yeah? And this part also minus with 2x plus 3. So you minus with something in the middle. So the answer will be, so what is that after you minus it? You will get, okay, I want to make a scratch here, yeah? So 6x minus 3 and then minus 2x plus 3 here. So this is for the car. So I want to write 6x minus 3 minus 2x. So I open the bracket, yeah? You multiply the minus inside here. So, and then minus 3. So we got 6x minus 2x, 4x, minus 3, minus 6. So this one is for the car. Okay, so the car here become 4x minus 6. And then how about bicycle? Okay, bicycle. Again, sorry, my mistake. So bicycle here is 4x plus 1 minus bracket 2x plus 3. Okay, yeah, now open the bracket. 4x plus 1 minus 2x minus 3. So we get 4x minus 2x, we got 2x plus 1 minus 3 minus 2. So here is for the bicycle. For the bicycle, we have 2x minus 2. Okay, yeah? So now we can add them all, because we know that the total people in the group is 50. So we can just sum them all, yeah? So first, so 50 people here is consists of the car owner, which is for x minus 6. This is the car owner only, yeah? And then plus the both car and bicycle, which is 2x plus 3. And then next is the bicycle only plus 2x minus 2. And then plus for those who doesn't have a car nor and also bicycle, yeah? And then plus 3x. We try to combine the like terms. We combine the x variable here, 4x plus 2x plus 2x plus 3x. So I got 11x, yeah? 11x and then minus 6 plus 3 minus 2. Okay, so I think I get minus 5. Okay, so 11x minus 5. Right, so this is 11x minus 5, then equal to 50. Then I move the 5 to the left, yeah? So 50 plus become the previous one, the minus 5 moved to the left become plus 5 equal to 11x. So this is 55 equal to 11x. Then x here, I move the 11 to the left, become division, yeah? So 55 over 11. So x here is equal to 5. Okay, so the value of x is 5. The question here is how many people in this group own a car but not bicycle? Another word here is own only car. Only car. So the number of people that own only car, so in the conclusion here, yeah, only car. Only car owner here is equal to 4x minus 6. You can see it from here. Okay, this is 4x minus 6. So we can just substitute the value of x to 5. So we have 4 times 5 minus 6. So we got 20 minus 6. So this one is 14 people. Okay, so this is the answer. I think that is for number 3. Okay, now this is question number 4. So a class of 28 students, so the total number of students is 28, yeah, this is the total, were surveyed and asked if they ever had cats, dogs, or turtles. Okay, so we have 3 animals here, so it's representing 3 variables. Okay, yeah, so the questions here, okay, so for pets at home, so 6 students only ever had dog and etc. Here this is the data, but the real question, what is the questions here? Hence, find the number of students who had 3 pets. So the question is, how many students had 3 pets? Yeah, so first, if we want to solve this problem, we need to draw a Venn diagram. Yeah, so I want to draw in the box first. Here I want to make a bigger one. Okay, here is the box. Okay, so this is the box, so I want to draw 3 circles. Okay, yeah, draw 3 circles representing 3 variables that we have: cat, a dog, and turtle. Okay, so like this. Okay, so this is too small. Yeah, I want a bigger one. So like this, like that, and like this. Yeah, okay, so no problem. Okay, so here is the things. This is representing the cat, for example, and this is the dog, and this one is turtle. Okay, and then now we try to input all the information here. So 6 students only ever had a dog. Oh, this one very important. Yeah, you need to pay attention. 6 students only, so there is word only here. So when there is a word only, you don't have to minus with anything because it's already dog only. Yeah, it's not mixed with any other animals, so only dogs. So it's located here. This is 6. Yeah, and then 4 students only, again here only, ever had cat, so cat is 4 students, and then 2 students only, this is also only, there is word only again, ever had a turtle, so 2 belongs to turtle here, turtle, and then 4 students had a cat and a dog. Okay, so for this statement there is no word only, so it will mix with the one who get 3 animals. Yeah, so 4 students had a cat and a dog, cat and dog, so this one is 4. Yeah, and then because the question is asking about the number of students who had 3 pets, so the location for 3 pets is here. This is the x. Yeah, so we are going to change here the x. Okay, so this one is the x. So we are going to find the value of x here. So now this one, because there is no word only, no only. Yeah, so there is no word only, so the cat and dog here can be mixed with the x, so we have to minus 4 here with x. Nah, this one like this. All right, next is here 6 students had a cat and turtle, so 6 cat and turtle, cat, turtle, this one 6, and this one there is no word only also, so you minus it with x. Yeah, and next here is 5 students, dog and turtle. Okay, dog and turtle here is 5, and you also must minus it with x. Okay, yeah, so and then 3 students never had any pets, so 3 students here is outside, so no, there is not in the circle. Okay, so 3 students has had nothing. Yeah, had no pets. Okay, so now it's time to see here, because the total student in a class is 28 students, so we can just sum them all. So you can say it like this. Yeah, so 28. Yeah, so 28 equal to, we can sum them all, so start from the middle, maybe x, and then plus 4 minus x plus 6 minus x plus 5 minus x, and then plus 4 plus 6 plus 2, and then the last one is plus 3. Okay, yeah, this one. So we add them all, it must be, the total is 28. So now we combine the x term, yeah. So how many x? One, okay, x with minus x gone, yeah. And then this is minus x minus 2x. So we have minus 2x, and then the number, we add the number together, we got 4 plus 6 is 10, plus 5 15, plus 4 19, plus 6 25, plus 5 is 30. So this one plus 30, yeah. Okay, so this is equal to 28. Now I want to move the minus 2x to the left so that it will become positive, yeah. So 2x here equal to 28 move to the right so that it will become negative. So 30 minus 28. Now this one. So 2x here equal to 2. So x here is equal to 1. So the conclusion here is there is only one student who own 3 pets, yeah. Okay, who own 3 pets. All right, so this is the answer for the questions number 4.